So if you were to explain to someone why we age, basically you want to explain to them an analogy of cars or laptops. When you have laptops, something who burns or gets hot, it uses up energy. And when it uses up energy, it does work. It allows you to power your monitor, your devices, it allows you to transfer that energy into peripheral devices such as keyboards, mouses. You can charge wireless spy cameras with them, which is kind of random because I have a spy camera. And then after a while of doing it, something happens. The joints aren't as strong as they used to be from the constant wear and tear. Um, After the chips start being burned, pieces start falling off, and then soon everything starts breaking. And the thing with laptops, unlike our bodies, that laptop doesn't have repair systems, so that it only lasts for an average of 4 years, whereas our body can last at this moment up to 90 or even more years, depending on our genetics and how medical uh, technology is. So another analogy would be to look at a car. A car can break just like the computer. The tires can be punctured, the engine can get clogged, and you know all this stuff about cars. The thing you want to know about cars and laptops is that it doesn't need to be an average of 4 years. The car doesn't need to have an average of, say, 10 or 20 years. There are cars in the street that runs at 50 or 60 years. You have laptops that are 15 or 20 years. And what the difference is that they have repair systems. I mean, not built in, but you get the point that we can repair a hard drive that's broken. We can repair a punctured tire. And it's the same thing with our bodies. Problem is, unlike cars and laptops, where we can fully repair it into a perfect new state, our body doesn't do that. It heals itself up to a certain warranty period, and that's about 27 years old, or 27 years. And beyond that point, we reach a point in which evolution has not given us the tools to repair ourselves beyond that point because we never needed to. Evolution only selects the qualities that will allow us to survive only to this certain point. So beyond a certain age, uh, our immune system doesn't work so well, and many of that is because of the accumulating um, cells are that are immune cells, but they are targeting. It's like in other words, it's an immune system that doesn't turn off. And what happens is when the immune system doesn't turn off, is that there's like a vicious cycle when you have diseases that can't be destroyed, or our immunity to the stuff like fighting off the common cold doesn't work so well, and so our immune system is constantly making more and more of these anergic cells that aren't destroyed, and now you have less cells, less space to attack future diseases. And you have other problems such as the clogging of our arteries. At a certain point at a young age, it doesn't build up so quickly, but it does build up. It doesn't lead to a critical point in which it will kill us because evolution selects us to survive till this point. But after we reach a certain point, the danger years of 30 or 40, 50 years old and beyond, then there's an exponential rise of heart disease and Alzheimer's. Both of them are caused by similar causes. Maybe the building up of plaque. What people don't understand is that they already know the causes of many parts of aging. Whatever causes the disease that kills us is aging. So what kills us is in heart attacks is the buildup of plaques. So the buildup of plaques would be aging itself. And there are many forms of these things. Aging isn't one thing, but we can categorize aging as a group of causes. Another reason could be the buildup of dangerous mitochondria in our cells, and that leads to different diseases like the mitochondriopathies. And you can characterize that by the swelling of our internal organs. Another kind would be Alzheimer's. That is the buildup of a different type of junk. They call it extracellular junk. And it's the same thing with the plaque that builds up in our arteries because the body can't get rid of them, and as a result, it chokes up our cells. It distorts homeostasis within our body, and eventually, well, if you don't have any brain cells, you're practically going to die. And in cases with Parkinson's, if you don't have enough cells that produce dopamine, then you start shivering all over, you can't control your muscles, and eventually you die. So the solution to this, as we practically know most of the causes of aging, which people don't understand. The main problem with aging is that people don't understand what aging is. They come up with the idea that, especially with it's the idea that keeps being repeated over and over again. It's a bad idea, but because it's repeated so many times, you actually believe it. They believe that aging is an inevitable thing, that it can't be changed. It's not like a disease. That's the thing. The problem is they don't see aging as a disease. They see it as a phenomenon that is beyond all control by predisposition. So they never question whether or how aging works. Isn't that a mysterious thing that all of us age and yet no one questions it? And then what makes it worse is that you have the TV commercials that features the crap information about aging. That if you take this vitamin C pill, or if you drink all these fruits, it's going to slow down aging because it has a heck ton of antioxidants in it. Well, the studies has shown that antioxidants, unless targeted into one aspect of our body, which is inside the mitochondria where there's a surplus of free radicals, if you just eat a bunch of antioxidants, it's absolutely not going to do absolutely nothing. And in other studies has shown that if you have a lot of vitamin E, it may even cause the spread of free radicals. Which what happens is that free radicals I mean if you don't know what radicals are, you're probably imagining them as like floating yellow balls of energy or you imagine them as like the evil Pac-Man going around chewing up your body. That's not really how it is. They're particles, and the most popular one is, or the most common one is superoxide, which is oxygen to the 2 minus. And it doesn't have or 2 minus or minus, but it doesn't have a full outer valence shell, so it's very reactive. So what happens is it converts one healthy molecule, such as vitamin E or lipoproteins, into damaged molecules. And the damaged molecule is what moves into other cells, and then it transfers the damaged poisonous cell to the other cell. So now the other cell becomes poison. So the problem is that, well, I focused on the problems already, but the solution to this problem is to get rid of the junk directly, and I'll explain that in future videos.